It is said that the impact on our environment from a single 100-watt bulb burning constantly for 1 year would be the equivalent of 280 pounds of coal, or 7 barrels of crude oil, or 7,000 pounds of wood burned, with 1,052 pounds of carbon dioxide produced. It is easy to see that a few small changes can have a big impact. In this day and age of environmental responsibility, it's all we can do to preserve our natural resources. The City of Tempe is taking steps today to ensure the preservation of our air, water, and energy resources. An essential part of our effort is a commitment to energy management overseen by our facilities maintenance section. They have developed a 3-part energy conservation plan consisting of building management, lighting, and design review of new construction. This program is designed to not only save energy, but taxpayer dollars as well.
This is a Robert Shaw building automation system, and in this particular building it is running the air conditioning, the heating, and the outside lighting. Its job is mainly to monitor all of the air conditioning systems, adjust room temperatures. It monitors the sunrise and sunset times and runs the outside lighting accordingly.
Computerized regulation of building temperature and exterior lighting is the heart of our building management program. For each building, an operating schedule is entered into the system. The computer then maintains proper building climate during the scheduled time, and exterior lights are turned on only from dusk to dawn. This scheduling system ensures that energy-hungry devices operate only when necessary.
The target advantage from any building automation system is to save money. By tightening up the time in which the air conditioning system is running, by tightening up the time the lights are running, by just basically keeping a better handle on the conditions in the building, they're able to save their cost very quickly.
Of course, many municipal buildings are used during non-business hours. For these times, a system override is available. Users simply press a button near the sensor and the climate control will be turned on for a period of 4 hours. This design helps maintain a balance between energy efficiency and flexibility. Most of us know the Arizona sun is great for getting a tan, but it puts a real strain on energy demand. So, large buildings rely on highly efficient chilled water systems instead of traditional air conditioning units.
At this location, we have a 300-ton chiller. We're taking water that's coming back from the buildings, bring it into this end of this chiller barrel. In the chiller barrel, we have cold refrigerant that's chilling this water down to approximately 45 degrees. It then comes through the lines, circulated through the pumps, and from this pumping station, it's pumped out to the different air handlers in the different buildings. In those air handlers, we take this chilled water. It is circulated through coils, which cools the air to condition the space in the different locations.
A secondary loop of the water runs through a cooling tower on the outside of the building. Here, evaporation chills the water and is used in turn to cool the machinery inside, and another purpose.
This heat exchanger, which is very similar to the one that we have in our police courts building, is used to take water from our cooling tower. It's circulated through this heat exchanger in those times of the year that we can get cold enough tower water in the cases of low humidity and lower ambient temperatures. We can get that chilled water. It goes through this exchanger and it cools the building water supply, which comes through these lines here. It's exchanging the heat between the tower water and the building water, cooling the building water so that we can maintain the building without having to run the chiller system.
The high efficiency of this system allows for district cooling, or using just one chiller to provide water to as many as 3 buildings. For instance, the water chilled in the library is used to cool the air in the Historical Museum as well. And plans are now being made to expand the chilled water system in the police courts building to also cool City Hall and the Performing Arts Center. When completed, 3 separate systems will have been replaced with just one. Although cooling is the major concern in the desert, efficient heating was the problem here at the city's vehicle maintenance facility. The old electric heaters could not overcome the effect of 12 bay doors constantly left open. Heated air was siphoned directly to the outside, with little or no effect in the work area. The solution was to install gas-fire radiant heaters. With a radiant heat system, objects are heated rather than air. Mechanics now work in comfort with warm tools and equipment, even when the doors are open. This heating design has reduced energy costs more than $9,000 per year. Another aspect of this energy plan is lighting at Tempe buildings and other facilities. The lighting system has been changed to maximize the amount of light while minimizing the amount of energy used.
The trick to saving money lighting-wise is to produce more efficient lighting. If you can downwatt and maintain the same lumens, then you're going to save energy.
Existing 40-watt fluorescent tubes inside municipal buildings have been phased out and replaced with more efficient 34-watt tubes and energy-efficient ballasts, a seemingly small change with big results.
6 watts don't make a lot of difference with one fixture, but then you figure that the building might have, the number of tubes in a building might be in the 5-digit range, 5,000, 10,000 tubes, so then that's 60,000 watts, not 6.
Area lighting is another candidate for an energy conservation program. In public areas, such as here at the Tempe Cultural Complex, security is a major concern. But with a few changes, a dramatic amount of energy is saved.
In this parking lot at the Tempe Cultural Center, there is a lot of lighting, 38,000 watts worth. We found that fully 2/3 of this wasn't needed after business hours. By reconfiguring the electrical circuits, we were able to shut off a large number of these lights, and it saved us $6,200 in the past year.
Needless lighting is also a major concern at Tempe's parks and recreation facilities. Field lights generate a lot of light and consume lots of energy, so it is important they are on only when absolutely needed. So computerized scheduling is used to help manage the problem.
The remote ball field lighting project that we're using here allows the community service people to schedule the lighting from a remote location. And they need not worry about the start time because there's an astronomical function that turns the lights on at dusk. The only scheduled time they need to worry about is the off time. We feel that that is giving us maybe half an hour to 15 minutes of advantage every day in that the lights are not burning unnecessarily. The 344 kilowatts of energy that are used to light these 6 fields represent a cost of $28 an hour to operate. So if you can shave off 15, 30 minutes of operating time every day, that does stack up.
Astro-digital timers are also being used at Tempe's other parks.
This is Kiwanis Lake in Kiwanis Park. We have recently installed a new high-pressure lighting system that consists of 25,000 watts of lighting. And to control that lighting, we have installed astronomical controls, much like this. This control knows the particular dusk time every day and turns the lights on accordingly. And we can program in the off time, which is the park closing time of midnight.
The key to the lighting plan is the same as you should do in your own home. Reduce wattage wherever possible. Use high-efficiency bulbs and fixtures and turn off all unnecessary lights. The third part of this energy management program involves design review of all new construction projects. In this process, city personnel make it a point to use the most efficient climate control and lighting systems.
Design review is one of the privileges that our maintenance department has that very, very few departments seem to enjoy. But we have the opportunity to talk to the engineers and architects of a new building or project with the city and voice our concerns as far as energy management, maintainability, just the general likability of the system from our standpoint. We get to include our past experience with buildings into the design of the building. It, you know, we have systems that have worked for us in the past. We get to convey that information to the engineers, and if at all possible, get the systems that we know that work into the newer buildings. Yeah. I think it's a very important part of the overall energy program. In order to save energy, you got to have the proper equipment and tools to do it with. When you're talking a new building, that has to be designed into the building from day one. Once a building is built, you're limited to what you can do and to what can cause a quick enough payback to make it economically feasible to do. It's much cheaper and simpler to do it as part of the original design.
These programs are examples of what the City of Tempe has done to conserve our natural resources, programs which have earned the city 6 consecutive energy-conscious community awards. We encourage you, whether it's at home or work, to do all you can to conserve energy and do your part to preserve our natural resources.